Okay, let's get started. Thank you all for coming. It's really nice to be in Krakow again. It's been 2 years since I've been here for a last conference. I think it's also GeeCON. And I'm very honored to be able to talk to you guys again, and girls, of course. So today I'll be talking about how to automate your software development experience and also delivery, so the entire CI/CD lifecycle and everything that's associated with that area of expertise. So I work for Atomist. Atomist is a company founded by one of the people that started Spring. So I'm one of the lead engineers of the team. We're based in San Francisco, and our goal is actually to modernize the entire CI/CD ecosystem to the 21st century and actually beyond that. So what's the problem that we are actually trying to solve? So everybody probably is using some sort of cloud native solution nowadays. So that what is that actually? So you have got the cloud native architectures, a lot of services, microservices, functions as a service. That also has a lot of deployment scenarios. So you can deploy to Kubernetes somewhere in the cloud, be it Azure, Amazon, Google, or something that's on-premise at your company. Or you can use one of the various cloud providers like Amazon ECS or Pivotal Cloud Foundry or anything other like Heroku. And one of the main aspects of cloud native architectures is that, and cloud native worlds, is that it changes very frequently. So there are a lot of stuff that are always being innovated upon. And yeah, it's not always that easy to, if you're in a company that is trying to keep up with the modern evolutions, to get your deployment mechanisms and your building mechanisms in sync with that evolution. So one of the things is that, like, for example, one of the top performing teams, they deliver a lot more frequent. So we're not talking about once a day, once a week, but multiple times a day. There have been numbers like 46 times faster than normal teams. They tend to just deploy into production or into testing environments. They also have much shorter lead time. So that means once a feature gets entered into the system, they have a much shorter lead time to get that into production or into an environment that's being confronted with real users. And they also have a lot fewer failures than other teams that tend to do like the big bang deployments. But of course, cloud, if you look at the software delivery, it has become a bit of a nightmare, at least on an organizational level. We're used to, like, if you look at the existing CI/CD systems, that was really interesting if you had like 1 or 2 or 3 projects in order to get those deployed. But now we're talking about a lot more projects that we need to deploy into production or other environments. And there is YAML everywhere. So if you look at existing solutions like a Travis CI, Jenkins, Azure DevOps, they all use YAML, and not just to define data, but also to define intrinsic behavior of the deployment process. So you're suddenly looking at decision structures inside of your YAML in some sort of declarative way. And that's not really very interesting when it comes to software delivery and testing that delivery in your entire company. So this is something that probably a lot of you people are acquainted with. So you start a new project and you need to build that project onto your own build systems. So what do? Well, you just take an existing project, you take the YAML file out of that existing project, you copy paste it in your own project, and you start changing it a bit. That works when you have like 1, 2, 3 services in order to just be able to maintain that. But Now scale that solution to 100 services or 1,000 services. That's not really easy when you're now suddenly have a huge fragmentation of your entire build process within your organization. And this is, for example, one of the two service meshes that are in very big companies like Amazon and Netflix. We're not talking about 100 services being deployed into production frequently. We're talking about thousands. Netflix is about, I think, 3,000 services that needs to be deployed at 3,000 projects within the company. So one of the issues that we're coping with is that we are actually blissfully unaware of the problem, because most of the time we're working in our own teams, in our own software, in our own product, and we're not really aware of the issue at hand because, hey, it works for us. It works within our own company. But imagine that you have a company that has 500 services, and suddenly the company tells you, hey, would you like to start scanning for CVE failures within your own application? Or do you want to publish your test coverage to a centralized service so that we can actually track the quality of our products as a whole? Now suddenly you are confronted with the fact that all your pipelines are fragmented within your applications. So you have one pipeline per project, which means you have to change sometimes over 1,000 YAML files in order to get that one single request of your business fulfilled. Sorry. For us, delivery, and that means CI, CD, and everything that's combined with that, is a blueprint. So basically, all of those 500 projects are doing somewhat the same thing. They are building the software, they are running tests, they are making containers, for example, if you're using Docker, and they are deploying to an environment that's defined within your company. That can be internal environments or like Kubernetes environments in the cloud. So you can utilize Atomist in order to realize that blueprint, to see the patterns within your applications and codify those patterns into a consistent and testable infrastructure and piece of code that you can run within your own company. So the architecture of Atomist is actually that the base system is that we have a So we have a cloud service that captures events within your own company. So for example, it captures all the events that are coming out of your source control systems, but it also captures events that are coming out of your issue management systems, existing build systems if you've got them, so you don't really need to throw away your entire Jenkins infrastructure if you're using Atomist. We can just capture those events and correlate those to the commits. You can use Docker, Kubernetes, or any other cloud environment like OpenShift or Cloud Foundry. We can also capture events from third-party systems like Sentry in order to capture operational events from your application. And we correlate those within our own system based on the SHA or any other correlation that might seem fit. And we expose that information through a GraphQL API. And that also connects to your chat ops system. So for example, if you're using Slack, which is the primary tool that we're using, we also support MS Teams at the moment. We expose that information to the chat system in one area, but we also expose that information to a software delivery machine. That software delivery machine is a piece of code that's running within your own infrastructure, and that will codify your development and CI/CD process within your own company. And will also relay that information back to the event system so that it can be shown into the ChatOps tool that you're using. So for us, the path to self-service software delivery requires 4 things. Integration, so all the systems that are existing within your own company For example, your source control systems, your issue management systems, or any other piece of information that's usable within a software delivery process. On the other hand, we want to correlate this information. So for example, if a build comes in, we want to be able to track which commit actually triggered that build, or vice versa. If we have a commit, we want to see which builds actually resulted from a commit. We also want to be able to automate this. We don't want to do manual stuff anymore. We just want to commit and just make sure that everything goes into production, completely automated. And we also want to be policy driven. So if you're in a big company with a lot of repositories, you sort of want to have a policy driven development process, which means everybody tries to adhere to the same standards, and it makes it much easier for people to switch teams if there is some sort of policy within your company, within the different projects. So for us, it's also about the rise of the developer. For us, for a lot of people, CI/CD is something like, okay, somebody else is going to do this. We're saying like, okay, no, you're a developer, you should be in charge of your own development process, and you should be able to codify that in a real language. So we want to drop YAML for true programming languages. So we don't start implementing if structures in a YAML file or worse. One of the key issues also, for example, with YAML is once you start bumping into the limitations of, for example, YAML structures within the existing CI/CD systems, people just say like, okay, I'll just write a bash script and call that bash script within my CI/CD YAML file. Who's actually using bash scripts in their CI/CD YAML files? Not a lot of people, but okay. So for us, in Atomist, the software delivery machine, the piece of code that's actually going to deliver your software and will contain all the logic that has that your development process has, is TypeScript code. It's testable, it's reusable, and it's clear. You can actually go through the code and actually see what the entire process is doing. And it's powered by a rich domain model. So we try to make an abstraction out of everything within a delivery process. And we ended up with a very rich domain model. For example, we codified what is a project, what is a commit, what is a push, what is a build, what is a container, things like that. And we merged that with a very powerful query system. So every piece of information that's coming out of your systems, for example, your SCM systems, we can query that and we can correlate that to other events within the system. So how does it look like, for example, the query system? Let me just... Here. It's a bit small, but yeah. So we can actually get all the pushes within a certain project, find out which goals are being set by our software delivery machine, see which commits are in there, and of course also what the build status was of that commit. So if we run that, you actually get, okay, this was a commit, this was a push which contained this commit that actually triggered all those goals within that repo, and the status was passed. So we actually can correlate all that information from all your existing systems. So how does it look like in code if we start programming a software delivery machine? So what I'm going to show you is a very basic software delivery machine that's going to build a Maven project. Actually, it's going to generate a Maven project for you. It's going to build it, it's going to make a Docker image, and it's going to deploy it to Kubernetes. So first of all, this is the most basic one that you can get. Is we have a couple of goals. For example, if we go to the push rules, we actually say on any push that happens within the system, we are going to do a couple of goals, which are the check goals. The check goals is going to do an auto fix. So one of the things that Atomist can do is actually fix your code for you. If you, in this case, there's an auto fix in there that adds a license file. So if your project doesn't have a license file, it will do it for you. One of the auto fixes that we use very regularly in our own projects because it's TypeScript is tslint. So we don't need to do tslint anymore manually. Atomist will do that for us. It will just do the fix for us and just commit for itself. And then we'll do a when the push satisfies is Maven, so we can actually test each push against certain preconditions. In this case, is Maven is one that we have built in. It just checks whether there's a pom.xml within your own project, and it's going to set another set of goals, which is in this case the Maven build goal, which is just a build with a Maven builder. We also support Gradle out of the box. So if I start up this SDM, so I do Atomist start. It's going to connect to our cloud service. And in this case, I have a GitHub organization that's also connected to the cloud service that actually uses webhooks to send that information to us. Very important, we do not send code over to our cloud service. The code completely remains completely within your own organization. For example, if you're using GitHub Enterprise, a self-hosted service, the code never leaves your own company. The only thing that is going to the cloud service is actually metadata about the events that are happening within your own company. So now it's started up the software delivery machine, and I can ask for an Atomist like, okay, what can you do? So these are actually all the software delivery machines that are running against my own team in Slack right now. A lot of them are public SDM that we provide as a service. But as you can see, I have one SDM running that's specifically running here on my own machine. And one of the skills that it has is create app from seed. I need to say who's the owner. So I have a lot of organizations within my own GitHub accounts that's linked to this one, as I'll use this one. And let's say GeeCON. That's the name of the repository. I need to add a Maven group identifier for the POM. And I need to add a base package for my own project. It's going to give me a summary of all the information. I'm going to submit that. So what it's actually going to do is it's taking an existing Spring application and it's going to clone that and it's going to transform that a bit. For example, if that Spring project has a certain package, it's going to rename those packages, going to rename the main class of that application. So it's really a new application, is not just a plain clone of the application itself. It has done that, and it's saying, okay, do you want to make a channel for this one? Yes. As you can see, it already started building my application. So it didn't do any auto fixes because there was already a license file within the application itself. There are code inspections, the push impact rules, and then the build itself. So I'll go to the application, to the piece of code, and let's say I remove that license file. There we go. So it actually detected that the license file is missing, and it just does an auto fix and just adds the license file for you. We also, for example, use that for maintaining code of conduct files within your own applications, or any other automated system that you can use. For example, code formatting. If you have a code formatting system, you can just do an auto fix and just commit, and the Atomist will just do the formatting for you. You don't need to bother anymore with looking at the code formatting. And it just did a build again. So the next thing that we're going to do is add Docker to our application. So there are a couple of things that I need to do for that. Docker has a concept of versions for their images, and that's something that we enforce within our own Docker build system, that every project has its own version, so that you can actually track the Docker images that are going out of your system. For example, with Maven, everything is a snapshot, but if you have multiple builds of a certain project, you want to have different versions of that snapshot within your own Docker registry. So we have something that's called a version goal. And we can say with versioner so this is actually going to take the version within the POM, and it's going to transform the version using the MVM version plugin to something that's unique. In this case, it's going to append a timestamp to the version itself. So I need to plan that that goal. So I'm going to say plan before I do the build. So it's going to change the version, and it's going to store that version within the graph, so that I can actually get that version from other systems as well. So in this case, I can also say, and the build goal needs to happen after the version goal. In this case, I can also say, okay, the Maven build goal from now on, if it has version information, needs to apply that version information for each and every build. So we can actually say dot with project listener, and we say MVN version. So now for every build, it's first going to do an MVN version within your own application. So now that we have that covered, we can actually now do a Docker build. So let's do const Docker build. And we're not going to push it right now because there's an internet connection here that's a bit slow. So if I start pushing images, but I'll be using Minikube anyway, and my Docker daemon is connected to the Docker image registry of Minikube. So that's not really an issue. So now that I have this, my TS-lint, I can actually make a new goal set. And I'm going to say like, okay, I want to do that after my build succeeds. And in this case, what Atomist actually does is for each and every goal, it's going to do a clean checkout. That's very important. For example, if you're using Atomist and you run it on a Kubernetes environment, it's going to do every single goal as a Kubernetes job. So you don't really have the usage of existing codes within separate goals. You can also cache them between goals, of course. But this is why we are actually starting from a clean checkout of the code, and our Docker builds will need the artifacts that are being produced by the builds. So I need to add two project listeners. One is the version goal, which will change the version of my application. And the second is a package. We will just create the outcome package of my application. So now I have all the goals, and now I need to plan those goals on a push rule. So I'm going to say when push satisfies has Dockerfile. So if it finds the Dockerfile within the project, is going to set a couple of goals, in which case the Docker build goals. Probably I'm missing a couple of semicolons. I'm probably missing a comma. There we go. So I'm going to stop the SDM and I'm going to restart it. Here we go. So it's been restarted. And now let's add a Docker file. So I'm just going to create a new file, Dockerfile. I'm going to say from adopt openjdk. Let's pull in latest. I'm going to expose the port that's being exposed by the application, in which case it's 8080. And I'm going to run a couple of commands, java -jar and app.jar. And I'm going to copy over everything that's in the target folder to app.jar. I think that should be right. And I'm going to commit that file. If you see any obvious mistakes in Dockerfile, please shout them out to me. There we go. And if I now look at it, has planned my Docker build file as well. So it's now going to do a Docker build of my own application and it's going to install it into the Docker registry in this point. So The next thing that I'm going to show you is one of the SDMs that we provide out of the box. It's called a Hoover. It's a very opinionated way of working. So it supports a lot of stacks. At the moment, it supports Maven, Gradle, and NPM stacks because we are using it internally also for our own deployments, Atomist. And Uhura out of the box supports also deployment to Kubernetes. So it's now doing a Docker build. There we go, and it succeeded. We can also see the logs, what actually Atomist is doing, because we stream those logs to our own service, and you can actually see what happened within the application. So in this case, it just made a Docker image from your application. But now I'm going to start up Uhura. So there we go. And let's start up Uhura. There we go. So if I now go to my application and I'm going to change a bit of code. For example, I just changed something in my POM. That will just trigger Atomist to do something because it needs to have a push to react to. It's going to say like, okay, Uhura has a concept of detection of your application, so you can actually see whether it can build your own application. In this case, it's saying like, okay, I can build this. Do you want to enable this? Because we don't enable Uhura by default, otherwise it would start building all of your applications within your own company. In this case, I'm saying, okay, yes. From now on, Atomist Uhura can start building my applications. So it actually didn't do anything because there wasn't any SDM enabled yet. So if I now start, and I'm also going to say immediately like, okay, add Atomists, configure. Configure the deployments. I'm going to say like, okay, I want to deploy to testing. My namespace of the Kubernetes cluster in this case is going to be testing. You can just change it to whatever you want. And it's going to ask me which cluster do you want to deploy this to. So in this case, I have a Minikube running on my own machine. And there is a SDM running within that Minikube that can capture events from our cloud service and just detect whether you have asked for a deployment to Kubernetes. So in this case, it's now my project is now enabled for deployment to Kubernetes. So if I now change something in that POM, I'm not writing any Kubernetes descriptors right now. So Atomist can actually detect how your application is built and it's going to make default descriptors for your application based on the information that it can find. So within the Dockerfile, for example, if it sees an expose port, it's going to make a service. If your Kubernetes registry, if your Kubernetes cluster has an externally accessible endpoint, it's going to make an ingress for it. So in this case, I'm going to commit the changes. And it's going to start doing the goals that are configured within Uhura. So in this case, it's going to do a versioning system because there are no auto fixes or code inspections planned. It's going to do the builds, going to do Docker builds. It's going to tag your builds for you within Git, so that you always have a certain point that you can go back to see reproducibility. And it's going to deploy it to a testing environment, which in this case is my locally running Minikube. Uhura also has caching built in, so if you have multiple goals that are reusing, for example, build artifacts, it can cache those artifacts and reuse them within certain goals. It's not enabled by default because of security reasons. Not everyone wants to cache artifacts within an external service, but it's very easy to enable that. So it has a Docker build, it's going to tag it. The tag will show up here in the tags. And you'll see a new goal coming up, which is it's going to deploy to the testing environment. Takes a bit of time because it needs to communicate with Kubernetes in order to get the information. There we go. So now it's deployed on our Kubernetes cluster, and I can. Takes a bit of time. Quickly check. So if I go to kubectl get pods -n testing, it's actually running. So let me check. Hey, so it's running. So took a bit of time to start up the container. Probably it needs to pull some images in. So now I just did one simple commit and it's been deployed to a Kubernetes environment. This is all running on defaults, but every default can be changed to whatever you want to. So what's the Atomist sweet spot? So if you have a lot of projects, and that can be like 40, 50, but you can also, of course, use Atomist for a small amount of projects, and you have a willingness to codify your CI/CD system. So you're sick and tired of all those YAML files within your application, and you have a lot of systems to integrate with, then Atomist is really a very nice tool to have in your toolbox. So what can you do with Atomist? You can build your software, you can deploy your software, which I've shown you. You can inspect code. I'll show you something after this that really is very interesting for that. You can correlate events from other systems. So if you have external systems, monitoring systems, it can actually capture those events and act upon those events. So for example, if you have stability monitoring of your own application, it can correlate those events. So if an application goes down, you can see which commits caused that application to go down, and it can actually also detect who did that commit and send that person a message to say like, okay, something went wrong after you committed to production. Of course, chat ops, because it's tightly integrated with your chat tools. And you can also promote just the standards and best practices of your own application and your own company, and a lot more. So with regards to inspection of your code, Atomist has access to the code in your organization. If you're using Atomist for a long time, you can start making diagrams like this. In this case, we analyzed which Docker images we're using within our own applications and within our own organizations. So this one is our open source, and these are all our other projects that we're running. And as you can see, there are a lot of different versions that we're using within our own applications. So this means that we have a lot of discrepancy within our own applications in order to see what happens. In this case, that's fairly normal for our customer SDMs because they are running on their own Docker images each and every time. But also something very simple. Within our open source applications, we want to see whether we also have a code of conduct within all our repositories. And something that we noticed, we have a couple of repositories that do not have a code of conduct file. That's something that we'll have to fix. But now at least we have the information within our own organization that we need to do that. So there is a lot of information within your organization's code, but there's not really a way to get through to that information. With Atomist, that's possible. So if you want to get started with Atomist, I suggest you go to www.atomist.com. And you can just sign up with your own GitHub account. You get a Atomist workspace, and then you can start linking Slack to that workspace. And we have a very nice developer manual in order to get running as quickly as possible. So what the future holds is actually a lot of up to the community. We already have support for Maven, Gradle, and Node, and also for .NET, which we demoed recently at MS Build. But if you have certain use cases, we're more than happy to hear it. We are also working on a much simpler way to define SDM. So now there's a lot of TypeScript code, but what we actually want to do is just make sure that you have to write one single TypeScript file to do a simple delivery of your own applications. And basically, we want to be able to do it in code. We started something called the Software Defined Delivery Manifesto, which actually says like, okay, we want to do delivery like we write production code. Our delivery is production code. So let's do it in real coding languages. And we are not the only ones. There are companies that are doing, say, also with TypeScript, for example, the cloud infrastructure management. So we're not the first, and we will definitely not be the last.